Question 3. You need to work out the radius, and they haven't drawn any radiuses in for you. So the first thing is to draw a radius. If you're ever stuck with circles, then joining the centres of something is probably a good idea. So draw the radius in, there's the radius, that's what we need to work out. We know that this is 4 root 3 from the question. If you half that on the calculator even, it's 2 root 3. So this is 2 root 3, this is r, and we now have a right angled triangle to work with. So we don't know what CD is, but we can use the distance formula to work out what CD is, and when we do that, it's 2 root 5. So this is 2 root 5, this is 2 root 3, and now we just do Pythagoras and you can work out r. So I'll show you my workings. So 2 root 5, and then we just do Pythagoras. So square the 2 root 3, make sure it's in a bracket when you square it, square the 2 root 5, add them up and square root, and you get 4 root 2. Okay, second part. Right, so they give you 2 circles, C and S, and from those 2 circles you can work out the centres and the radiuses. So we'll start with C first. So half the 4 and flip the sign, you get -2. Half the -2 and flip the sign, you get 1, and that's the centre. For the radius, you have to use the radius formula. Okay, so g squared, f squared, and minus the k. So put that all in and you should get 10. That's the radius formula. Page 19, I think you'll find that one at the bottom. This one here, S, so just swap that sign, 7, swap that sign, 13, so that's your centre, 7 and 13. Square root this, and again there's a formula on page 19 showing you where that is. So r is 5. So now we know where the centres are and what the radiuses are. So quick sketch. If 2 circles touch externally, this is what that means. And a rule for you, if they touch externally, if you add the 2 radiuses together, you should get the distance from these 2 points. So it should be the same. So if I can work out the distance from this centre to this centre, it should be the same number as if I add the radiuses together. So first thing I want to do is add the radiuses together. So 10 plus 5, 15, job done. And then I work out the distances from this centre to this centre, and I can just use the distance formula for that. So I use the distance formula, it's 15, this is also 15, they touch externally. There is another type of question where they touch internally. I might just do a little internal. So internally would look something like that. I've just done a drawing off the screen, whoops. So internally is that, okay, touching internally. That would be if you subtract the radiuses, then it's the same as this distance here. So the other one is if you add them, and the internally one is if you subtract them. Right, we're nearly done with this question. So there's an infinite number of circles that touch circle C externally at the same point that S touches it. So that is true, and it's basically saying we could just draw lots of circles here, and they could be bigger or they could be tiny, but they'd all touch at that point. But basically they'd all be on this line. So if you sort of join them up, they're all kind of touching there. So all I've done here, I'm not sure it's the best way, but it's certainly the fastest, is say, right, if we start from the centre of C, which is -2, 1, how do we have to move to get to the centre of S? So let's try and get the drawing here as well. If we start here, what changes about the coordinates to get to there? Okay, so if I start from there, what happens to get to there? What happens to -2, 1 to get to 7, 13? Well, you're going to add 9 to the -2. So if you add 9 on, you get 7, and you're going to add 12 on here. And as long as you do a multiple of this, then you'll be here. You'll be on this line and you'll be touching externally. So what I've done is I've just doubled both those numbers. So add 18 and add 24, and I've come back to here. It doesn't have to be double. You could triple it, you could half it, you could times. As long as you've got a multiple of it, it will work. Although, let me have a think. I think you might need to have a number bigger than 1 for it to be externally. Actually, I don't think you can do fractions, because then you'd end up inside. So yeah, double it, triple it, times 10, whatever. But if I double, get 18, double the 12, you get 24, and then just add those on. So add the 18 on, add the 24 on. And 16, 25. Again, there's an infinite number of answers here, but that's one of them.